Hello everyone. Through this video we are going to discuss about cube and cube roots. So preliminary informations regarding this. Say we are considering any number a. Here in this case, if I get a in the form a into a, then it can be expressed in the form a to the power 3. This whole quantity is known to be the cube of a. Suppose, for example, I consider a number 6. Cube of 6 is what? Cube of 6 can be written as 6 cube. 6 cube means 6 into 6 into 6. The result comes as 6 6 are 36, again multiplied by 6, 6 6 are 36, 3 left, so it is 216. So this type of quantity, this is known to be cube of the number cube of 6, and 6 is known to be the cube root of 216. We all know that square root can be expressed by this notation, yes or no? Like 25, square root of 25, the result we get as 5. Now cube root can be expressed in the form, this 3 is not multiplied here, this 3 is written in a very small way. Along with it, suppose I am writing here 216. This is cube root of 216 and answer will come as 6. So this is the relation between cube and cube roots. This is exactly similar to square and square roots, but square refers to, square means power 2 and cube means power 3. That's all. So with this we are we can find out the perfect cube or the roots, cube root of a cube number using prime factorization method basically. So I'm going to start with exercise 7.1. The first question says what? This is question number 1. Question number 1. In question number 1, what is there? Which of the following? Which of the following numbers? Which of the following numbers is not perfect cubes? Is not perfect cubes. So there are 5 numbers given here. I shall pick up 3 numbers out of this and proceed. So I'm taking the first one. Given number is 216. So by prime factorization, all of you know what is prime factorization because that is already done in the chapter of square and square roots. By prime factorization, what did I get? 216, that is an even number, so will be divided by 2. 2 1 are 2, then 2 8 are 16, then by 2 again. This is again an even number. 108 is an even number, so 2 5 are 10, 2 4 are 8. By 2 again, the result comes as 27. Then again by 2 it is not divisible. 27 is an odd number, it is divisible by 3. 3 9 are 27, again by 3 3 are 9. So by prime factorization, what do I get? 216 is equal to 2 into 2 into 2, again 3 into 3 into 3. So we find that these three numbers, 2 comes in the group of three numbers, and here this number 3 comes in the group of 3. That means triplets we are getting here. So we can write here 2 cube into 3 cube. So powers, if we take common, so we shall be getting 2 into 3, power is common, so it is 6 cube. Or we can write it in the way, there is a way of writing, that is what, instead of this we can write in what way? We can write it in the way 1 2 taken from here, then 1 3 is taken from here, then again another 2 into 3, again 2 into 3. So what we shall get? 6 into 6 into 6. So it is 6 cube. Therefore 216 is a perfect cube. That's the way to solve. Then again I'm coming to the second one. The second number given here is what? 128. So by prime factorization, 128 can be written in what way? Let us check. 128 by 2 if I divide it, so it will be 6, then 4, then again by 2 it is 3, 2, then by 2 it is 16, then by 2 it is 8, then by 2 it is 4, then again by 2 it is 2. So in total how many 2's we get? 1 2 3 4 5 6 7. 7 2's I am getting here. 2 into 2 into 2 into 2. 4 2's I have written here. 2 into 2, how many? 1 2 3 4 5 6 7. So if I consider the triplets, then this 2 is left behind, this 2 remains unpaired. Since, so I have to write here, since 2 does not get included in the group of trees, hence 128 is not a perfect square. It is not a perfect square. Again, coming to another one. So in question number 2, what do I get? Find the smallest number. Find the smallest number by which each of the following numbers must be multiplied to obtain a perfect cube. To obtain a perfect cube. So in this case again there are 5 numbers given. I shall proceed with picking up a few out of this. So the first number here is 243. 243. So of course I prefer to proceed with prime factorization method. By prime factorization, what do I get? 243. So by prime factorization, 243 by 3 I have to divide 81 here, by 3 again 27, then by 3 it is 9, then by 3 3. I get here 5 3s. Out of this, 3 3s are grouped in 3s and 2 3s remains unarranged properly. So one more 3 is required for arranging it in the group of 3s. So what did I do? Since tree does not appear in group of trees, therefore 243 is to be multiplied by 3 to make it a perfect cube. So this is the answer for it. Then coming to the second one. In the second question, second number of this part, what do I have? 256. 256. So by prime factorization, I get 256 as 256 when divided by 2. This is 1, then this is 2, this is 8, then by 2 this is 64, then again by 2 it is 32, then again by 2 this is 16, then by 2 it is 8, then by 2 it is 4, then 2 2. How many 2's do I get? 1 2 3 4 5 6 7 8. There are 8 2's here. 2 into 2 into 2 into 2 into 2 into 2. 1 2 3 4 5 6 7 8. 2 more 2's are there. So this is grouped, this is grouped. We can say that one more 2 is required here to make it grouped. It clearly, to make it cube, one more 2 is to be multiplied, and that is the answer. Similarly, I shall come to another one. Roman 4 I am picking up. This is 675. By prime factorization, what did I get? 675. Let us check. 675, is it divisible by 3? Yes, it is divisible by 3. 3 2 just 6, then after 25, then again by 3. Yes, it is divisible. 75 by 3, it is 25. 5 5. So very clearly one more 5 is required to make it cube. So 3 into 3 into 3, this is already grouped. Then 5 into 5. So very clearly one more 5 is needed. Very clearly very clearly to make it cube, it should be multiplied by 1 more 5, and this is the required answer. Then after, the remaining sums of this number can also be done in the same way. Next, coming to question number 3. So in question number 3, what do we get? In question number 3, what is asked? Find the smallest number. Find the smallest number by which each of the following numbers must be divided to obtain a perfect cube. So here also there are 5 numbers given. I shall be picking up last 3 numbers. So starting with Roman 3, given number is 135, given number is 135. So by prime factorization, what do I get? 135. That will become 135. Can I divide this by 3? Is it possible? Yes. By 3 I can divide. 3 4 are 12, then 5. Then again by 3, this is 15. Then by 3, this is 5. So very clearly these 3's are already grouped in 3's. So 5 is left. Clearly 5 is to be removed from 135 to make it a perfect cube. Therefore 135 must be divided by 5. Then coming to the next number, Roman 4. In Roman 4, the number given is 192. So by prime factorization, what did I get? 192 is equal to, let's proceed, 192 divided by 2, 2 9 ja 18, 2 6 ja 12. Then after by 2 again it is 48. Then by 2 again it is 24. Then again by 2 it's 12. Then again by 2 it is 6. Then again by 2 it is 3. So very clearly this 3 is extra. These 2's are already grouped except 3. So the factor 3 does not appear in a triplet. Therefore 192 must be divided by 3 to make it a perfect cube. And that's the answer. And the fifth one under this is 704. So by prime factorization, what do I get? 704 is equal to, let us proceed here, 704 by 2 we can proceed because this is an even number. Then I get here this result again by 2. 2 1 ja 2, 15, 2 7 ja 14. Then after 6. Then again by 2 I can divide this. 2 8 ja 16, again by 2. Then again by 2 I get here 44, again by 2 this is 22, again by 2 this is 11. So very clearly 11 is ungrouped here. So 2 into 2, then 2 into 2 into 2 into 11. So this is grouped, 11 is ungrouped. Since 11 does not appear in a triplet, hence 704 must be divided by 11, to make it a perfect cube. So that is how this type of questions could be solved. Then the last question of this exercise, we shall come to question number 4. So here is question number 4, the last question of this exercise. What it says, Parikshit makes, what is given? Parikshit makes a cuboid, of plasticine of side 5 cm, 2 cm, 5 cm. How many such cuboids? How many such cuboids will be needed to form a cube? Will be needed to form a cube. So coming to the solution part, what is given here? The measurements are given to be 5, 2 and 5. So we find that these are not in form of triplets. So to make it cube, one more 5 will be required and 2 more 2's will be needed. So I shall write here, given numbers are 5, 2 and 5. Since 5 and 2 are not found in the form of triplets, means from each kind, means there should be 3 5s and 3 2s. Therefore, to make it cube, we have to multiply 5, 2 and 5 by 2 into 2 into 5, means these two extra 2's should be required for making a triplet and triplet. Again this extra 5 is needed for making these two in the group of 3. So 2 into 2 into 2 into 5 into 5 into 5. So how many extra things we shall need? So of course very clearly this is the extra part we need here. So we can write removing this is not required. So we shall write here, to make it cube, the number 5 into 2 into 5 must be multiplied by 2 into 2 into 5, that is equal to 20. So 20 cuboids will be needed to make it cube. So that is how it can be solved. So with this exercise gets over. Thank you.